Hi, in this video, we're going to learn how to solve simultaneous equations, and we're going to use two different strategies, which is elimination methods and substitution methods. All right, so let's get started. Before we start, what is simultaneous equation? Is when you have a pair of two equations. So it can be something like 2x plus y equals 6 and y equal 4x minus 3, something like that. So this is a pair of simultaneous equation, and we want to know what is the x value and what is the y value. But when we substitute back in, they equal to each other, right? Now I'm going to do the first method is substitution methods. So let's start with example A. If you have something like 2x plus 3y equal 4 and y equal 5x minus 1, something like that. And the question asks you to solve for x and y. Now, you can see here in the second equation, y equal something here. So we're going to apply the methods for substitution methods. So we use substitution methods. So what that means is we're going to substitute y equal 5x minus 1. We sub that into the first equation, which is where you have letter y here. So we sub that into here. So what we do is we're going to write the first equation, 2x plus 3y equal 4. Okay. And letter y, you're going to replace letter y at 5x minus 1. All right. So 2x I write again, plus 3 right again, but instead of writing y, I won't write y. I'm going to write 5x minus 1. So 3 times bracket 5x minus 1, like that. So I replace y by 5x minus 1, and I'm going to let that equal to 4. So from here, you can see that the equation all have letter x. So you can solve for x from here by expanding it out. 3 times 5x, 3 times negative 1. So 2x right again. 3 times 5x is 15x. 3 times 1 is equal 3, equal 4. And then 2x plus 15x is 17x minus 3 equal 4. Then I can solve by doing the same on both sides. So opposite of minus 3 is plus 3 on both sides. I would have 17x equal 7. And then opposite of divide by 17, times by 17, I'm going to divide by 17 on both sides. I would have x equal 7 over 17. Sorry. So when you solve for x, the next thing you're going to do is you're going to substitute x 7 over 17 into one of these equations to solve for y. And obviously the second equation is easier to sub in because you know y already as a subject. Okay, so we're going to sub x equal 7 over 17 back into here to find y. So that's step 1. Step 2 is sub x equal 7 over 17 in y equal 5x minus 1. So we have y equal 5 times x is 7 over 17 minus 1, like that. So when you're dealing with fractions, sorry, 5, you make 5 is 5 over 1, and then you just times fraction together, right? 5 times 7 is 35. 1 times 17 is 17, minus 1. And now if you want to take away fraction, you make 1 over 1, and then you make them the same denominator again. The denominator is 17. I'm going to times this by 17, and this by 17, like that. So I will end up having y equal 35 minus 1 times 17 is 17, 35 minus 17 give me 18, and the denominator is 17. There you go. So in here, I can answer the question. So the answer for this question is when x equals 7 over 17, y will be 18 over 17. Okay. We're going to do another example, but this time we're going to think about the applications in the graph. So example 2, let's say they want you to find the intersections between two lines, so between y equal 2x plus 5 and y equal 3x minus 1, something like that. So if you think about 2x plus 5 is a linear line, like that. So think about one line, 2x plus 5. 3x minus 1, 3 is a gradient, so they're a little bit steeper, so one go like that. So they want to know when the two linear line is drawn, what is the intersections that will pass through by two lines. So we want to know what is the x coordinates and what's the y coordinates. So this is another application of simultaneous equation. We just solve for this one. So I can write them together as y equal to x plus 5, and this is y equal to x minus 1. So what you can see here is y equal this and also y equal this. So this is basically another way to think of substitution methods. So if you substitute y equal this into letter y of the first equation, you can let that equal to x plus 5. So technically, we're saying that 3x minus 1 we replace in here. So we would have 3x minus 1 equal to x plus 5. Or you can say they both equal y. So of course they equal each other. Okay. Then opposite of 2x is minus 2x on both sides. So 2x and 2x go away. 3x minus 2x is 1x. 1x minus 1 equals 5. Then you can plus 1 on both sides, like that. So you would end up having x equal 6. So you know that this point here have x equal 6 as the x coordinates. Then I can find the y coordinates by writing. So I sub y in here. So y equal to x plus 5. And I know that x equals 6. So I sub 6 in. So y equal 2 times 6 plus 5. 2 times 6 is 12. 12 plus 5 is 17. Okay, so I know that the y coordinates here is 17. Therefore, the intersections, and you can write that as a point which is 6, 17, like that. Right? Note that when we do substitution method, it doesn't have to be y equals something. It can be x equals something if you think that if you see that x already has subject. Let me give you an example. If I say x equal 5y minus 1 or something, and I have negative 2x plus y equal 1, something like that here. So here you can see x as a subject here. So you can substitute x into the second equation. Okay, so as long as one of the letter is as a subject, you can do that. So I will have, so instead of writing negative 2x, you're going to write negative 2. And then letter x, you're going to reply letter x as 5y minus 1, like that. And then plus y equal 1. And then you can solve from here for y. You will get negative 10y plus 2 plus y equal 1. Negative 10y plus y, negative 9y plus 2 equal 1. So you would have take 2 on both sides. Negative 9y equal negative 1. Then you divide it by negative 9. You would have y equal negative divided by negative 1 over 9. So when you solve for y, you can substitute back in and you solve for x. All right. So x is 5y minus 1, and you know y is 1 over 9. So what you do is substitute 1 over 9 in, and you can get x. So 5 times 1 over 9 minus 1. 5 times 1 over 9 is 5 over 9 minus 1. 1 is 1 over 1. So make the same denominator. We times by 9 on both sides. 5 minus 9 is negative 4. So negative 4 over 9. So we have, this is the x coordinates and this is the y coordinates. So we got x and y. Okay, so all the examples that I have done so far is substitution methods. So we use that when one of the letter is by itself, is as a subject. Now we're going to move to another method, which is elimination. So with eliminations, let's say how that different. I have 2x plus 4y equal 1. 3x minus 4y equal 6 or something. So if you can see here, none of the equation have y equals something or x equals something, so I can't substitute anything in, right? So I have to come up with a new method, and that method called elimination. Elimination means you're going to eliminate one of the variable. So how do we do that? If you see you can see the 2x and the 3x, they are different coefficient. But if you see the 4y and negative 4y, you can see they're the same number, but one plus and one minus. So to eliminate them, if you just plus them in the middle, 4y plus negative 4y, actually you can cancel the y out, and you can solve for x from there. Okay, so that's called elimination. I'm going to put the plus in the middle here. Oh, sorry. So 2x plus 3x give you 5x. 4y plus negative 4y, they go away, as you can see. And 1 plus 6 equals 7. There you go, very fast. And you can solve for x from here. You divide it by 5 over, so x equals 7 over 5. So it's very quick, right? Then when you get x, then you can substitute x back in any other equation. You can solve for y. So let's pick the first equation. So the first equation is 2x plus 4y equal 1. And I'm going to sub x equals 7 over 5 in. Okay, so I have 2 times 7 over 5 plus 4y equal 1. 2 is 2 over 1. 2 times 7 is 14. 14 over 5 plus 4y equal 1. Now, up to this step, if you didn't want to deal with fractions a lot, what you can do is you can get rid of fraction by this is over 5. Can you see that? So I'm going to times by 5, times by 5, and times by 5. If you times by 5 for every single terms, you actually have no more fraction. So when you times by 5 here, the 5 and the 5 cancel out. So you're left with 14 plus 4y times by 20y, and 1 times 5 equals 5. No more fraction. Then you can go from there. So minus 14 on both sides. 14, 14 go away. I have 20y equal 5 minus 14 is negative 9. Then you divide it by 20. Divided by 20. You would have y equal negative 9 over 20. There you go. So you get the answer here when x equals 7/5, y equal -9/20. Okay, so this is just a simple example elimination. So what happens if these number are not the same or are not the uh, um, and we cannot plus them or subtract them to cancel them out. So what do we do? Now let's do another more complex example. If you have something like 3x minus 4y equal 2 and 2x plus 5y equal 1, something like that. So you can see if you look at the x, 3 and 2, they're different. The y is 4 and 5, they're different. So I need to make one of the variable have the same number. Okay, so I'm going to choose x because 3 and 2 look smaller than 4 and 5. So what I do is basically you make them the same denominator. So 3, that's 2. So if you want to make x the same, 3 here, you're going to times by 2. Okay, and 2 you're going to times by 3. By doing that, you're going to make them the same. You can say same multiple. 2 times 3x, you're going to times everything here by 2. 2 times 3x is 6x. 2 times 4y is 8y. 2 times 2 equals 4, like that. Then you do the same here. 3 times 2x is 6x. 3 times 5y is 15y. And 3 times 1 equals 3. Okay, now you can see I have 6x and 6x here. So if I have the same number, if I put the minus in between, actually 6x and minus 6x will go away. Okay, so if they're the same number, you can subtract them to make it eliminated. So it's 6x minus 6x go away. So I have negative ay minus positive 15y. So like that. Negative ay minus positive 15y. So negative and positive is negative. So you can think of negative 8 minus 15. That gives you negative 23y. Let's go here. Negative 23y. Okay, equal 4 minus 3 equal 1. Like that. Then you can solve y by divide by negative 23 on both sides. So you would have y equal negative 1 over negative 23. So the negative we put in the middle, so negative 1 over 23. It looks nicer that way, right? And then once you've done that, you can put it back and solve for x. So you can put into either of those equations. So I'm going to choose the second one. Okay, look. So x plus 5y equal 1. So I'm going to sub y equal negative 1 over 23 in. Okay, so I have 2x plus 5 times negative 1 over 23 equal 1. 5 is 5 over 1. 5 times negative 5 over 23. And plus 2x here equal 1. So as I say, to get rid of fraction, what you can do is you can times everything by 23. So times this by 23, times this by 23, times this by 23. Okay, 23 and 23 go away. 2x times 23x is 46x minus 5 equal 23, like that. So opposite of minus 5 plus 5 over. So 46x equal 23 plus 5 is 28. And then divided by 46, x equal 28 over 46. That gives you 14 over 23. So this is the x coordinates and this is the y coordinates, right? So in summary, we just learned how to solve simultaneous equation using elimination and substitution methods. So what's the recap here? If you see y equal an equation here, and you have another equation. You have an equation here. So if you see a format, something like this, or you see x equals something, and there's another equation here, right? Then with any of these format, you can use substitution methods. So use substitution methods, substitution. Because you can see if it y equals something, you can substitute that into this equation. And same thing, if you see x equals something, you can substitute x into the other equation. So that's called substitution. And if you ever see something like 2x plus 5y equal 1 or something, and you can 3x minus 6y equal 2. If you ever see something that difficult to substitute and it have nicely arranged x, y, and the number, then this one you're going to do elimination methods and eliminate by making one variable the same coefficient. So same coefficient. So for example, you can determine that you're going to make x and x have the same coefficient. So it means 2 here, you're going to times the whole thing by 3. And 3 here, you're going to times by 2, something like that. So make them the same coefficient so you can subtract them, or in this case, you would subtract them to cancel them out. So subtract them to eliminate, to cancel that out. Okay. But just be careful. In this case, you subtract because 3 times 2 is 6, 2 times 3 is 6. So you would minus to cancel the x out. But if you ever see something like 5x minus y equals 4, negative 5x plus 2y equals 6, here it already have the same coefficient. If you not the negative, but because 1 plus and 1 minus, so you would add them. If you add them, the 5x and the 5x, the negative 5x will go away.